By the end of this lesson, you should be able to solve problems involving pressure, temperature, and volume of a fixed mass of gas. From the results of the previous 3 experiments, we notice there is a relationship between the pressure, P, the absolute temperature, T, and the volume, V, of a fixed mass of an ideal gas. If the temperature of the fixed mass of gas is constant, we obtain Boyle's law, PV equals to constant. If the pressure of the fixed mass of gas is constant, we obtain Charles's law, V over T is constant. If the volume of the fixed mass of gas is constant, we obtain pressure law, P over T is constant. The above results can be combined to form the combined gas law, PV over T is constant, or P1 V1 over T1 equals P2 V2 over T2. Helium is a gas that is used to fill up balloons. Helium's non-combustibility and high buoyancy, second only to hydrogen, make it the most suitable gas for balloons and other lighter-than-air aircrafts. A gas cylinder contains 0.05 cubic centimeter of helium at a pressure of 16,000 kilopascal. The gas is used to inflate balloons. Each balloon, when fully inflated, contains 0.04 cubic centimeter of helium at a pressure of 102 kilopascal. The temperature of the helium inside both the cylinder and the balloons are the same. What is the maximum number of balloons that can be fully inflated using this gas cylinder? Given that V1 equals to 0.05 cubic centimeters, P1 equals to 16,000 kilopascal, P2 equals to 102 kilopascal. Temperature is constant. P1 V1 equals to P2 V2. V2 equals P1 V1 over P2 equals to 16,000 times 0.05 over 102 equals to 7.8 cubic centimeters. Volume of each helium balloon equals to 0.04 cubic centimeters. Therefore, the total number of helium balloons equals to 7.8 over 0.04 equals to 100. A cylindrical flask is fitted with an airtight piston that is free to slide up and down. A mass rests on top of the piston. The flask contains a gas at a constant temperature of 313 Kelvin. The pressure of the gas is 137 kilopascal, and the height of the piston above the base of the flask is 23.4 centimeters. When additional mass is added to the piston, the height of the piston decreases to 20.0 centimeters. What is the new pressure of the gas? Let the cross-sectional area of the cylindrical flask equals to A centimeter squared. Given that V1 equals to 23.4 times A cubic centimeters, P1 equals to 137 kilopascal, T1 equals to 313 Kelvin, V2 equals to 20.0 times A cubic centimeters, T2 equals to 313 Kelvin. temperature is constant. P1 V1 equals to P2 V2. P2 equals to P1 V1 over V2 equals to 137 times 23.4 times A over 20.0 times A equals to 160.3 kilopascal. Consider again the cylindrical flask fitted with an airtight piston. The initial temperature of the system is 313 Kelvin and the pressure of the gas is held constant at 137 kilopascal. The temperature is now increased until the height of the piston rises from 23.4 centimeters to 26.0 centimeters. What is the final temperature of the gas? Pressure is constant. V1 over T1 equals to V2 over T2. T2 equals to V2 T1 over V1. T2 equals to 26.0 times A times 313 over 23.4 times A equals to 347. The figure shows an apparatus designed to operate on the principle of expansion of gas. The function of the apparatus is to give an audible alarm when the temperature in a cylindrical tank exceeds the set temperature. At that temperature, the expansion of the gas in the cylindrical tank pushes the thread of mercury in the glass tube towards the small gap between the electrical terminals at C. The mercury will close the electrical circuit, thereby setting the alarm off. What happens to the position of the mercury thread when the atmospheric pressure increases? A higher atmospheric pressure will push the mercury thread into the cylindrical tank. What effect will the increase in atmospheric pressure have on the temperature at which the audible alarm is activated? It takes a higher temperature in the cylindrical tank to set the alarm off. If the volume of the gas in the cylindrical tank is 50 cubic centimeters at 27 degrees Celsius and the atmospheric pressure remains constant, what will be the temperature of the gas if its volume increases to 55 cubic centimeters? Given data, V1 equals to 10 cubic centimeters, T1 equals to 300 Kelvin, V2 equals to 15 cubic centimeters. Pressure is constant. V1 over T1 equals to T2 over V2. T2 equals to V2 T1 over V1. T2 equals to 15 times 300 over 10 equals to 450.
Drag and drop to complete the chart.